honored to be given a chance to speak here on this very interesting topic. When I first heard design, my mind very traditionally went to like, oh, design like for engineering, for work, designing software, designing things like that. And you would think that would be pretty easy for me to just easily go to design automation, which is my field, and pick something from there to talk about today. But Nicole and Gloria really kind of expanded my mind with this because design really does apply to so many different facets of our life. And I picked something that is very close to my heart that I really want to address today. And it's not design automation, which I also love very much. So we're all here at the IEEE Future Leaders Forum. So I'm guessing a lot of us are a little bit nerdy, maybe, a little bit geeky. I'm a little bit myself as well. So a lot of us are probably familiar with the basic fundamentals of electrical engineering. And most of us has probably heard about Ohm's law. So we know that the current follows the path of least resistance. So today, I wanted to talk to you about redesigning the world in which, following the path of least resistance, it is easy for a girl or a woman to end up in a technical field, to stay on that path. Unfortunately, today there's way too much resistance in that current path. There is not enough amplification, and sometimes even diodes in reverse. Just like an inefficient circuit, I think this world requires a redesign. So let's start by first addressing two facets that we can address today, and this is out of many out there. One is expectations, which can be linked to resistance, but could be turned into amplification. And the other one is exposure, which is amplification like crazy. So think of this scenario. A young kid approaches a parent or a teacher or somebody in their community, maybe a family member, and tells them, hey, I want to explore engineering, or I want to join a robotics team, or maybe I want to take a shop class, or something like that. What would the response be if this young child was a girl versus a boy? So think about that for a second. In an ideal world, the answer should be the same for both. Unfortunately, this is not the case in many scenarios today, even though it should be. When I was growing up, girls were ushered off to take home ec class, while the boys got to take a machine shop class and have fun there. And it wasn't really a choice that we had, and our community was guiding us this way. It's not the case for every school, but it is the case in many scenarios. I've spoken to Latina women in engineering who, when they were trying to pursue an engineering degree, were told that they're better off bartending. Yeah. They made it through, though, with stubbornness. And, you know, if you check out the toy aisles in many stores today, although Toys R Us is closing down, or even search toys for boys and toys for girls on Amazon, you will see a trend there. You will see more intellectually stimulating toys, more macho toys being geared towards the boys, and a lot of pink and fluffy and cute stuff being geared towards the girls. Although I did see one Lego kit on there, but it was a mechanics shop, so that was kind of cool. In my honest opinion, I think both toys should be targeted towards both genders. Really, it should be a mixture because we need to explore different diverse parts of ourselves, and it shouldn't be so binary. So we really need to redesign the expectations that we have of our young women, and maybe put a little bit more amplification on their path and encourage them to pursue these things. It shouldn't, you know, we shouldn't have so many forces going against somebody's path towards a technical field. When you have so much going against you, it is really no surprise that so many people get taken off that path. When somebody you really care about, who you're supposed to look up to and who's guiding your life is telling you or routing you towards something else other than tech, it's quite easy to really stop thinking about it at all. So one way to counter this is to counter the bias within our society and within ourselves. I bet many of you have heard about breaking bias classes so far. Raise your hand if you have. So that's one thing. If you have a brain, you have a bias. It is a given. You can't say, I don't have any biases. The key here is to recognize it within yourself and then to work towards countering it, or just recognizing that you could think about things in a more broad way. So there's many companies that are actually teaching these classes now, and you can actually go to one today. Well, it's not a class, but this topic will be addressed in a diversity and inclusion panel this afternoon. My husband, Brian Cover, and his fellow panelists will be talking about this subject. And I think that's the one way you can start today. And by starting with ourselves, we can move on to our community. It shouldn't be an anomaly that a young girl is taking a machine shop class. It should be a totally normal occurrence with no congratulations and nothing like that. It's just like, oh, machine shop, cool. So speaking of shop class, let's talk about exposure. How do you know if you're good at something if you've never even heard of it or tried it? You can't, you don't know. And I strongly believe that every young and curious mind, no matter what gender, no matter what race, no matter what, should be exposed to the joys and fun of engineering. Doesn't mean they should pursue it as their career, but they should be at least exposed. So let me tell you a little bit of my personal story of how I ended up in engineering, how I ended up here. By the time that I started high school, not a single person has talked to me about pursuing engineering, about engineering as a field, about engineering as something I could study or even be interested in or try. I have played with Legos though, so I like that stuff, and I did program my TI 83 Plus Silver Edition. But I was strongly headed towards biology and chemistry. And it was really by random luck. I was walking around the hallways in my high school, my freshman year, and I came upon two posters. One was a photography club, and the other one was a robotics team, First Robotics. So you learn how to take really nice photos, learn about materials, metals, machine shop, electronics. Both sounded pretty interesting, but in the end, I was really intrigued by robotics. I wanted to give it a try. I've never heard of anybody talking about it to me to go and try it, but I thought maybe this is something that could be really fun. Well, for the next 4 years, I really got to enjoy myself doing mechanical as part of a robotics team, exploring many different aspects of engineering, because for First Robotics, it really is like different facets of engineering coming together. Electrical, design, machining, programming, all kinds of stuff. I got to cheer for our robots in stadiums filled with us nerds, and it was so much fun. I've got to hear from companies actually talking about careers in engineering. I got role models like Dean Kamen, who started First Robotics and invented the Segway. I've got to hear from founders of Google. I got to hear about the scholarships and all these opportunities. Now, I was still on my track for biology and chemistry, but then by the time I reached my senior year and it was time to choose my major, it kind of hit me. Hey, why don't you actually take this hobby of robotics and combine it with what you're interested in? So instead of applying for biology and chemistry, I started applying for biomedical and chemical engineering, with an open mind that I actually might like something else in engineering as well. Well, after I made it to Columbia University, I met this amazing professor, Valancourt, if any of you have ever heard of him, because he's awesome and crazy. And I fell in love with electrical engineering and never looked back and stayed on the track. I had a ton of support there, and I truly loved it. So it was because of this exposure that I received through First Robotics, because of these mentors who took the time out of their day to actually come and mentor us kids in our high school, because of all of this community coming together, and even one person just saying, hey, engineering is fun, you should look at scholarships, you should look at the degrees. That's why I ended up actually pursuing this path. Had I not found those posters my freshman year, none of this might have been here. I might not have been part of IEEE, which would have been very sad. So this is why I teach my Maker's World workshops. This is why I go out of my way to go and teach young high school girls and even younger about the joys of circuits and code by using Arduinos, by using wearables to just get them excited and get them to try that out. Again, I don't believe that every single girl should be pursuing engineering or should be excited by it, but I do believe that she should have at least a choice, at least an idea that this exists out there. And I think every young mind really should. Another great thing about trying something hands-on is that then it doesn't seem so scary after all. It doesn't seem so difficult or out of reach or too hard. When I went back to my high school after I started working at IBM to talk to the high school students who were picking their majors, I got this overwhelming response about engineering. It's too hard. I can't do this. This is coming from kids who go to Brooklyn Tech, a specialized science high school. Clearly, those kids were not a part of a robotics team. Because once you try those things hands-on, it really makes a difference. Of course, I talked to them and tried to persuade them otherwise. But nothing quite beats that exposure of trying it out, even for half an hour. When I teach my classes to the young high school girls, a lot of the girls, not a lot of them actually, some of them, when confronted with a technical task, like coding their circuit, will tell me, but I don't program. And I tell them, but now you do. And then, in an hour and a half, they crank out 3 projects. Circuit and programming, done. And maybe next time somebody tells them that engineering is too hard, they might think otherwise. They might think not at all. And they might actually consider engineering as their degree going forward. So, my Maker's World workshop that I'll be teaching later today is kind of centered around the same principles. A lot of us are working in high-tech stuff. We're pretty out there. But a lot of us are not makers or are even afraid to touch a microcontroller. Not because we're not capable, but because we're scared. We've never done it before. We're afraid of failing. Some of us buy it and it sits there on a shelf for 2 years. Well, today, if you attend my workshop, the participants will actually get hands-on with stuff. I'm not going to teach you about the principles of electrical engineering, but you are going